Hey everyone, welcome back. In this video, we will continue our discussion of K-maps. We are going to talk about 5 variable K-maps. Then we'll learn some techniques for the simplification of such K-maps, and we'll also learn about reflection and overlay maps. And then finally, we'll discuss K-maps with don't care conditions. So we'll see what don't care conditions are and how they are dealt with when they arise within a K-map. So let's first start with 5 variable K-maps. So we've already discussed 2, 3, and 4 variable K-maps in part 1 of this topic. So the simplest way to represent a 5 variable K-map is to basically draw a couple of 4 variable K-maps for 2 values of one of the variables. So here what we've done is we've taken one of the variable a separately, and then for the 2 values of a is equal to 0 and a is equal to 1, we have drawn 2 4 variable K-maps, number 1 and number 2. Alright, so this is the simplest way to represent a 5 variable K-map. We will go on to discuss 2 more ways in which we can represent 5 variable K-maps, but we're starting with this one. Alright, so for a is equal to 1, we have this type of K-map, and the numbering of the cells, you'll recall from your typical 4 variable K-map, the numbering goes like 0, 1, 2, 3, 4, 5, 6, 7, then you skip this row, start the numbering from here, and then you come back to this row. And the same system is then followed for the second 4 variable K-map, that is for a is equal to 1. Alright, so we left off at 15, so here we start with 16, 17, 18, 19, 20, 21, 22, 23, then skipping this row, 24, 25, 26, 27, and then coming back to this row, 28, 29, 30, 31. So we have a total of 32 cells, and the numbering goes like this. Now what happens in this set, so this together represents a single 5 variable K-map, right, for variables a, b, c, d, e. Now in this case what happens is cell 0 is considered to be adjacent to cell 16, this is adjacent to this, 1 is adjacent to 17, 3 is adjacent to 19, and so on. So this on the whole forms one single 5 variable K-map, and the adjacency, aside from the normal adjacency, right? So this is a whole adjacent group, this is an entire adjacent group. So aside from this, there is adjacency across these 2 4 variable K-maps. So 0 is adjacent to 16, 1 is adjacent to 17, and so on. Alright, so let's take a quick look at an example of how to simplify 5 variable K-maps. So suppose this is the expression given to us. This is 5 variable expression, and from this summation sign, the sigma sign, you can see that these are minterms. Now another way to represent minterms is like this. So small m with subscripts represent minterms. If it had been something like this, then that would have meant max term, right? So you remember our discussion of minterms and max terms from part 1 of this topic. So this is the expression given to us, or this may be given to us, and the idea is for each of these cells whose number is written here, we have to put a 1 in the resultant K-map. So let's first draw the K-map for this given expression. So it looks something like this. So for a is equal to 0 and a is equal to 1, we have just made all the entries. Now we will proceed with the normal method of simplification, which is we have to start forming the groups. And since this is the minterm form, we will make groups of the ones. Alright, so let's first start with the left hand side and just start forming the groups. So in this specific part of the 5 variable K-map, you can see that these are the groups that are now formed. So this is the first group, and we are going to write the names of these groups along with the formation of the groups, right? So this is the first group, this is the second group, the third group, the fourth group. And then we follow the same system of grouping of adjacent ones on the other side, on the right hand side of this K-map, right? So we can start forming the groups here. This is the first group, this is the second group, all right? Now the next thing you can do is, since this on the whole is an entire 5 variable K-map, and we've already discussed that cell 0 is considered to be adjacent to cell 16 and cell 1 is considered to be adjacent to cell 17 and so on, which means that we can actually form groups across these two separate parts of the 5-variable K-map, which means we can have groups like these, this new group, right? So this and this forms a group of 4 adjacent ones. Alright, so this kind of mirroring is also possible because now we're talking about 5-variable K-maps. The same map is spread across 2 parts, but it's still the part of a single 5-variable K-map. So this kind of mirroring is also possible, right? So we give a name to this group as well. So finally, we can say that this given expression can be simplified as this. Now you'll notice here that, as we have discussed numerous times in part 1 of this topic as well, that the way we group the ones together will differ across different people. Alright, so since this kind of mirroring was possible, that means this some of the groups from this part of this left hand side part of the 5-variable K-map could have been avoided, right? Some of the ones that are overlapping could have been avoided. For instance, this and this could have formed one group, so we would have avoided this green part. All right, we would have this black group, this red one maybe even, right? And then this and this could have formed one group of 2 ones. All right, so we would have no need for this green group. So we can make changes to this. So the idea is you have to proceed the best way you seem fit. All right, start with the largest group. Mirroring is also possible, so you have to keep that in mind while simplification of 5-variable K-maps, and then you have to avoid overlapping as much as possible. All right, so again, the resultant expression would depend on what kind of groups you've formed. All right. Now let's take a look at the 2 main alternative representations of 5-variable K-map. So the one that we just saw, in which we spread this 5-variable K-map across 2 sets of 4-variable K-maps, is one of the methods, is the simplest method. Then there are 2 other ways we can represent 5-variable K-maps. These are reflection maps and overlay maps. So we're going to discuss each of them in a bit more detail now. So let's first start with reflection maps. How do we represent a 5-variable K-map in this form? This is what it looks like. Now you'll see that in this version, when we represent 5-variable K-maps in this reflection map form, we can see that all the variables are put together in the same map. So there's no division of the map as such. We have A, B on one side, and we have the rest of the 3 variables on the other side. So you have to keep under consideration, the only thing here is this numbering. How does this numbering go? All right, so this is important. And how are the cells numbered now? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And now why is the numbering continuing like this? The reason for that is you have to think this dividing line, this one in the middle, think of it as a mirror. All right, think of this as a mirror, which means that this part and this part, these 2 halves of the 5-variable reflection K-map, are essentially mirror images of each other, which is why I've chosen to give different columns different colors, right? That's for to make it easier for you to see which column is a mirror image of which column, which basically means which cell is supposed to be adjacent to which cell. All right, so these 2 blue columns are mirror images of one another. If there's a 1 in this column and if there's a 1 in this column, these 2 ones will be considered adjacent. All right, then this column, this column is adjacent to this column. If there's a 1 in cell number 25 and there's a 1 in cell number 29, you can form a group of these 2 cells because they are considered to be adjacent. Then these 2 green columns are considered to be adjacent to one another, and then this pair of yellow columns is considered to be adjacent to one another. So this is visualization using colors is just to help you get an idea of which column is supposed to be considered to which column. That is, which cell is considered to be adjacent to which cell, because that helps you form groups of the ones. right? If you're talking about SOP, we have to form groups of the ones. If you're talking about POS, we have to form the groups of the zeros. The point is, think of this central line as the mirror, and then this half is essentially a mirror reflection of this half. This is what a 5-variable reflection K-map looks like. So let's take an example and see how to simplify a 5-variable K-map in the reflection format. So suppose this is the expression given to us, all right? So this is the resultant K-map. And now we have to start making the groups of the ones. All right, let's see how we can do that. So this is the first group. All right, so we can start from the left hand side, then we can move on to the right hand side, and then we can take a look at the combined groups, just like we did in the case of the previous example where we took 2 separate 4-variable K-maps. All right, so this is the first group that we can see is formed in the left hand side of this 5-variable K-map. This is the name of the group. Then this is the second group, the third group. Then we're moving on to the right hand side of this K-map. This is the fourth group, and then we can start making groups across the mirror, right? So this is the mirror. We can start making groups across the mirror and then give names to these groups as well. And the idea is to cover all the ones. And then we have another group. This is just from the right hand side of the K-map. And then we have another group which is formed by combining the ones from 2 different sides of this K-map. So you'll see, this is why we said that this is a mirror, because now this is a mirror image of this. Now you have to be very careful, because when we talked about K-maps, where we were discussing K-maps in the form of 5-variable K-maps in the form of 2 separate 4-variable K-maps, this one would have formed a group with this one, because this cell was considered to be adjacent to this one. But now this is the mirror, which means this is adjacent to this. All right, and this would have been adjacent to this. If there was a 1 here, then we could have made a group of these 2 ones. All right, so you have to be very careful. Think of this central line as the mirror, and you have to imagine how a mirror works. All right, so this is the final answer. And again, depending on which groups you're forming, your final solution could be different. All right, now let's talk about overlay maps. Overlay maps. How do we represent a 5-variable K-map in this format? So this is what it looks like. Now, why is it called an overlay K-map? There's a very simple reason. See, although we are representing this, and in appearance it looks similar to the 5-variable reflection K-map, the difference between this one and the other one is this part, the second half of this K-map, is actually supposed to be overlaid on top of this half. All right, so now this central line is not a mirror. The central line is not a mirror. Instead, what you have to visualize it, how you have to visualize it is like this. So suppose that this half of this, you take out this half of this overlay map, and then you put this on top of this one. And that's why they overlay. They overlay on top of each other. That's why it's called an overlay K-map. And again, this coloring I've done so that you can try to get an idea of which cell is adjacent to which cell. All right, since this half of the map is supposed to overlay on this half of the map, which means these 2 columns are adjacent to one another. These 2 columns are adjacent to one another. These 2 columns are adjacent to one another. All right, so if there's a 1 here and there's a 1 here, then you can form groups of these, right? So this is how a reflection K-map is different from an overlay K-map. All right, the difference lies, first of all, in this numbering. You'll notice the reflection K-map uses the gray code. This is not a gray code though. All right, so this is the first difference. The second difference is the adjacency of the cells. So again, I've used colors just to help you visualize which cell is supposed to be adjacent to which one. So in a reflection map, this half is a reflection of this half, but in an overlay map, this half is supposed to overlay on top of this half. So now when you're clear with the numbering and the ordering of the cells, and you're clear with the understanding of which cell is adjacent to which cell, we can take a quick look at an example of how to simplify a 5-variable K-map in the overlay format. All right, so suppose this is the expression given to us, and this is the resultant K-map for this. This is an overlay method now. All right, so you have to be careful of which groups to form. So we can start with the left hand side of this map. Oh, so it's all together. Okay, so you can later take a look at all of this, and you can see how these groups are formed. This is on the left hand side, this is on the left hand side purely, left hand side, left hand side. Then these are the groups on the right hand side, these ones. All right, and then we can make groups across these two halves. So this one can form a group with this one can form a group with this one, and then finally this can form a group with this. Again, based on how you decide to form the groups, your final simplified expression will be different. All right. Now let's talk about K-maps with don't care conditions. So sometimes we have functions or circuits where it doesn't matter where the output is 0 or 1. It can be either. The point is there are certain outputs which don't exactly matter to the overall functioning of the circuit, right? So the output could be 0 or 1. The point is we are not concerned with whether or not it's 0 or 1, all right? So these conditions, these specific conditions where the output doesn't matter to us, the actual value of the output doesn't matter, are known as don't care conditions. Now in K-map, these don't care conditions are marked with an X. So we don't put a 1 there, we don't put a 0 there, we just put a X. That is, we don't care. All right, so this is what it looks like. So here we have a simple illustration of a 3-variable K-map with certain don't care conditions. So this is a 1, this is a 0, which is fine. These three are then don't care conditions. So we don't care if this X is 0 or 1. It doesn't matter to the grand scheme of the circuit, right? In the form of a Boolean expression, it's written like this. So we have the minterms. Cells 0, 2 and 7 are supposed to contain 1s. The rest of the cells are supposed to contain 0 except these 3 cells. So don't care conditions, cells with don't care conditions are represented with a D. D stands for don't care. And then these cells are supposed to contain X's. 1, 3 and 5, 1, 3 and 5. So aside from 1, 3 and 5 and 0, 2 and 7, if we are left with any other cell, we'll put a 0 there. And this is what a K-map with don't care conditions looks like. All right, let's see how to simplify such maps. So the process of simplification of K-maps with don't care conditions is very simple. What we do is we simply consider these X's to be 1s. See, because we don't care if it is 0 or 1, right? So according to our needs, we can consider this X to be a 0 or a 1. So if you're trying to simplify a K-map in SOP form, where we group the 1s together, so we'll consider these, we'll pretend that these X's are 1s, right? If on the other hand we were simplifying the map in a POS form, so we would have to consider that these X's are 0s, all right? So based on our requirements, we can pretend that this X is a 1 or a 0 and then make the groups like we used to, right? So if this is the given map and this is the map that we have to simplify, what we do is we start forming the groups by considering these X's to be 1s. So this will be the first group, all right? This is a group containing 4 1s, and this will be the second group, right? So we're simply pretending that the X's are 1s. And then we give the names as we do. And this is how you simplify K-maps with don't care conditions. And similarly, we can have 5-variable K-maps with don't care conditions, right? The idea is all of these are minterms, so all of these cells are supposed to contain 1s, and then all of these cells will contain X's. And since we are doing this in SOP form, then that means that these X's will be ultimately considered as 1s, all right? And then we can form groups of these ones. The thing to keep in mind here is that although we are pretending that these X's are 1s, we are only doing that as long as we have a 1 that we need to form a group of, all right? So for instance, this entire thing can be considered to be one group. Similarly, this entire thing can be considered to be another group. This can be considered to be another group. All right. This can be considered to be another group. The point is, since this x is left, we are not concerned with forming a group for this x. We can form a group for this one. This is fine, because we have to include all the ones. We don't have to include all the x's. So although we pretend that these x's are ones, we only do that as long as there's a one that needs a buddy. All right. All the x's that are left don't have to be grouped together, because then we are thinking of this as 0. We don't care about this x. We're not concerned with this x. We are only concerned with it if it helps us form a group with some ones. So you can try solving this on your own. You can try this simplification. And here you can see that we have chosen this form to represent our 5-variable K-map. You can either use an overlay map or a reflection map. So whichever method you find best, right? Whichever method of representation you feel most confident with, you can pick that method, unless it is specified in the question itself about how you have to solve the question. So in that case, you will have to use that specific kind of representation. But if it is not mentioned in the question, then you can use any of the 3 representations of 5-variable K-maps that you feel most confident with, right? Because in the end, the point is simplification. All right, so that's it for this video. Just a quick recap. We talked about 5-variable K-maps, and we saw how 5-variable K-maps can be simplified. We also took a look at overlay and reflection maps. We saw how they are different from one another. We saw how they can be simplified. And then we talked about don't care conditions, and we saw how don't care conditions are dealt with when they arise within K-maps.